I'm gonna talk about coding for refactoring. Is a different side of looking at technical debt. As you can tell, at Dashlane, we are like scared about technical debt. That's because we worked on an app that was developed 10 years ago by 3 people that were out of the college. So they didn't have a lot of experience. They did an awesome job. But after 10 years, the code base was legacy. And 1.5 years ago, we decided, like, have you ever worked with legacy code? Okay, so what is the thing that you ask your stakeholders? Like, please, let me redo this from scratch, right? Yes. 1.5 years ago, our stakeholder gave us this opportunity, and I was the tech lead of that project, and I was like, okay, what do I do now? And like Jonathan said, where like you can be the best developer, you can have years and years of experience, but you're gonna end up with legacy. So this is what this talk is about. It was just the introduction, and this is a talk that wants to reduce the scare of legacy code. So or refactoring. The word refactoring is like, you talk about refactoring in a sprint review, people are gonna freak out, run away, and so this is from niter to an edit, because refactoring should be an edit. So, about myself, I'm Paola Ducolin, I'm Italian, I'm not French, I'm not Portuguese, I don't speak at all Portuguese, sorry. And I'm tech lead at Dashlane for the Windows team. I have more than 10 years of experience in C++ and C#, so no JavaScript, but I did a bit, because I like coding, I love coding. And I have more than 8 years of experience with legacy code, because except for one job, I always work with legacy code. And you can follow me on Twitter on Paola Duco. So if you want more information about this talk, or if you want to maybe create a new QueerJS meetup in Lisbon, just tweet me, and then I'm gonna reply. So this is a fairy tale. Once upon a time, there was a software company where the user clearly know what they needed. And the roadmap, since the user, the user need was so clear, the roadmap was well defined, like for the 10 years to go. And the UX and UI were straightforward, and the designer, like in 2 days, defined what the design was supposed to be. And the architecture was state-of-the-art, and every developer in the team was a huge expert of that architecture. And they lived happily ever after with a perfect project with no legacy. And no, that's not what happened. So as I was telling you before, 1.5 years ago, we started the revamp of the Windows app that is the most used platform of Dashlane. We have, I think, 1 million users, regular users, so no pressure. We have multiple target persona. I don't know if you're familiar with the persona concept. It's like an abstract target user. And we had 2 personas that died while we were developing, because we decided to change. Yeah, we don't know if they died or if they moved to LastPass. Maybe they moved to LastPass. I don't know. And a roadmap that is iterative, because we don't know what the user needs. So we use data to follow the user needs. So we are basically collecting data from the legacy app and see which are the features that they are most using. But we don't know if they are using that because they can find them. And they don't use the others because they are hidden in the code, hidden in the code. So we are going to do an iterative roadmap. We want a native testable UX, which is fairly doable on web. On native, it's a bit more complicated still. And we chose I was part of the decision to use a new technology that no developer in my team that changed, also the team changed, no developer knew anything about it. Like, I had 5 years of experience on C#. We chose to use C# and .NET. I had experience, and I was the only one, and I didn't consider myself a user expert. So, how do you do? Because all code is legacy code eventually. So what do? You can stop coding and you can find another job, or these are 3 tips that helped me and my team in the development of the last year and a half. So the first tip is write clean code. What does it mean? So first, we're going to start with abstraction definition. And abstraction is the amplification of the essential and the elimination of the irrelevant. So I find this and the next quote really useful for the naming. So if you need to name a function or name a variable, you need this name. This name is going to be an abstraction of what the object is. And you need this to be as clear as possible. So this is very useful. I read about it in a workshop that I joined, that I participate to, and the purpose of abstraction is not to be vague. That is usually what we do. Well, yeah, that's like the carpet, and we're gonna put the dust on there. But to create a new semantic level, in which one can be absolutely precise. So the goal of naming is giving a definition that the user of the code, so the other developers and yourself, because I forget about what I write after one day, you don't have to go look behind the code, behind that function, to know what the function does. The name should tell you. Yeah. So naming is important as naming your firstborn child. Maybe also your second-born child, but that's important too. If you're not Chris Martin and Gwyneth Paltrow, let's name your Apple, maybe it was important for them. So I will have some examples that I did around a rectangle that I consider to be a familiar object to anyone. So here we have an example of unclean code where we have L and H and this public function, it is a val size that is doing this multiplication. So if we go looking behind the code, we know that if the surface, this is a function that calculates the area. But if you find this function outside, you're gonna need to look into it. So the good way of refactoring this, or our way of refactoring this, would be to name it evaluate area, because that's what it's doing, and rename also the private members with length and age, because like it's 5 chars, it's 10 chars totally. You don't lose a lot of time by writing it all, and you will save time when you come back to this code and you're gonna use it. And no need to read inner code, as I said. So this is an example. This is an example. I invented it. I made them up. I didn't want to use real code because I couldn't find code that I wrote that was not because I didn't write ugly code, but because I didn't have time and a will to find it. But I'm sure there is a lot. So you have this function, it is increase size, and you pass float number 0.3. What do you think this function will do? Increase size. No, because it takes a percentage, it multiplies for the dimension, so passing a 0.3 will reduce the size. Yeah, I'm evil. So this is a way to refactor it. I name the function by what the function is doing. Scale, length, and age by factor. It is a long name, you can end up with long names, but who cares? Now it's clear. If you hide the code behind, you know what it's doing. Yeah. So functions should do one thing, and you should minimize the function length because this makes it more readable. One thing that I forgot to say is that we read the code much more than we write it. You write it once, you read it all your life, like for 10 years, we are reading our legacy code. So keep that in mind when you write the code. This is an example that I didn't make up, that I copied from a workshop that I participated to. And but I think you can find in every code base an example like that with a lot of if, no else, and like property that are changed in different places. So that's very complicated to know where you're going to in this. You really have to like take paper and take notes to know where this is going to. So a way to refactor this is to first put together the part of the code that are changing the same properties. Okay, so I took paper and I made squares around it, I made rectangles around that. And then I will do an adjust segment. So I took the blue part and I call it adjust segment because it's adjusting the segment. And I pass the same variable that the main function is taking. So I take the code, I write an else because it's more readable, and I do the same code. So the output will be should be the same. If you add a test, you'll be safer. But that's it. So same for tier. I take the code in orange and I put it in another function, and the end result is this. So the adjust function is doing adjust tier, adjust segment, and adjust promo. Another point is top-down narrative. I sometimes discussed about that with my team. I think it's really important because when we read the code because we are humans. We read the code as a book, so we read top-down. So what does it mean? It means that like the caller functions should be above the callee function, the call function, so that you read. So one bad example, in C# we have regions. So you usually, because it's Visual Studio that made them, you have these by default regions that are private methods, public methods. So by visibility of the members and not by function. So usually you have private methods and then public methods that is using actually the private methods. And you can imagine you can have 20 private methods and 10 public methods. So like that is quite hard to follow the code. And a way to improve it is to split the regions by function and top down. So you have the public function that is called at the top, and you have then scale length and scale 8, and they are defined just under the caller function. So other 2 tips are review with a team or work on open source project and have peer reviews, because that helps a lot improving. I think I made the best improvement as I joined software companies where I have more expert colleagues or colleagues with different experiences that could review my code and like being passive aggressive with comments. You know that. And also use refactoring tools like ReSharper for C# and for Visual Studio. It works very, very nicely. It points out at part of the code that can be refactored. like kind of automated. So you can improve also by that. But keep being human and use peer reviews. So the second tip is iterate over versus over-engineer. And this is something that I learned by experience, so by facing it, because I don't know about you, but at engineering school, we are taught to over-engineer. So when you do your coding school, they teach you that you have to, especially if you studied objective programming, you have to abstract everything. You have to like have, oh my God, you have to have functions that work for every case, every possibility. You have to be flexible with your code, like 10 years in advance, without knowing what the code is gonna do. And this brings to over-engineer and to overcomplicate code. So this is a quote by myself. Don't do today what you might not need tomorrow. Keep it simple and iterate on code. Do you want to take a picture?
I did it.
Okay, sorry. So how to iterate over versus over engineer. This is my recipe, sorry. And because I'm very bad at design, very bad. The way I iterate is doing a functional version. For example, for a new feature, I do a functional version, a very ugly, but functional version of the feature. And then I make it beautiful with the help of a designer. So while I do the functional implementation, the designer is doing his magic and is preparing his mock-up on Figma, for example. And then I can integrate it and then do it performant. So let's iterate. Try not to do everything at the first launch, because at the first pass, because you're gonna take a lot of time, and it's better to start testing over the functional implementation and go on with that. Okay. So here's some small tips. So develop as your code will be refactored tomorrow. And this is kind of, don't do today what you might not need tomorrow. And keep in mind that your code is probably going to be refactored tomorrow for the point that I did at the beginning. So avoid useless features, optimize for change. And if you want to learn more about that, there is philosophy that is AHA programming, that is avoid FT abstraction, that is duplicate code as long as you can. And then if you really have things that you can merge together, do it, but like eventually. So don't worry about duplicating code. That's also something that at engineering school, like if you have two functions in, like you have an animal with 4 legs and you have a car with 4 wheels, the engineering teacher will tell you, no, you have to find an abstraction that has some common, but no, one is an animal, one is a car. You can leave them. You can duplicate the code. It's not a problem. And last but not least is test, and test again. And I leave it for last because I need to come out to you, and I hate writing tests, and I usually don't do it. So yeah. But I talk about it because like you should do it. It's like when you go to the doctor and they say, yeah, you should eat a fruit every day. Yeah, I don't. So write testable code. This is a thing that I do. So you should. No, I'm kidding. But this is a thing that helps writing readable code. Is write testable code. So write unitary functions that with the idea in mind that you should test it, and you don't have to write a test. I don't. But that helps. And write unit test, integration test, and end-to-end test, right, to test all the chain. And what we have in place at Ducolin that really help is weekly manual tests, so QA. Thanks. It will cover for the test edition right now. You should write tests. I should. It's gonna be my 2020 objective. So the takeaways of this talk, I'm reaching the end of it, is write readable code. Sorry, I have it with the test. Write testable code, and do not write code that you don't need. And that's it. Thank you.